Alright, so today we're talking about the angles of polygons. First, we have to talk about polygons in general. Now, you've heard of polygons since you were in middle school, and a polygon is just a closed figure with 3 or more sides. Okay, now the important part there is it has to be closed, and if it only has 2 sides, it cannot be closed. So your examples of a polygon would be your triangle, your rectangle, or your rhombus or parallelogram. Okay. Or you could have even funky shapes that look something like this because it's a closed shape. Okay, so any of those would work. Now, are not polygons, okay, are anything that is open. Okay, so if it looks like this, that would not be a polygon. Or anything with a curved side. So a circle is not classified as a polygon, a semicircle is not classified as a polygon, a heart couldn't be a polygon. Okay, so a polygon has to be closed and it has to have 3 or more sides. Now, when it comes to polygons, we're going to have 2 different types of polygons. We're going to have a concave polygon, and then in a second we're going to have a convex polygon. So if you look at the concave form or concave definition, we have when one or more interior angles measure greater than 180. Okay, so that means that one of our angles is going to have to go into our shape to be more than 180. So when we think of concave, we want to think of it caving into our shape. So like I drew a second ago, if it comes inside our shape and then comes back out, then that would be a concave polygon. Our concave angle would be our angle at the vertex that is inside the shape. So from here to here, that angle would be more than 180 degrees. Now, our most common concave polygon is a star. Okay? A star would be considered a concave polygon also. Now, convex polygons are when our interior angles measure less than 180. And those are our typical polygons. Those are our rectangle, our kite or our rhombus or our diamond. Okay, you could have a pentagon. Okay, you could have a triangle. All of those would be considered convex polygons. Okay, so moving along. Then you also can classify polygons as irregular or regular. I'm going to start with regular because you are more familiar with those regular polygons. Okay, when we have a regular polygon, that means that all of our sides and all of our angles have to be congruent. Both of those things have to be true. So when we think of a 3-sided polygon, we think of a triangle. Okay, but with a triangle, if it's a regular triangle, then all of our sides and all of our angles are equal, which means it's actually an equilateral triangle. So we have to be more specific when it's a regular polygon. Okay, 4 sides, anything with 4 sides is just called a quadrilateral. But if it's a regular quadrilateral, all the sides are equal and all the angles are equal, which means it would have to be a square. We can do this all the way down our polygons list. So here I've gone from 5 down to 12. So 5 is a pentagon, 6 hexagon, 7 is a heptagon, 8 octagon, 9 nonagon, and 10 is a decagon. Now for 11, there's 2 different names for an 11-sided figure. I typically use an undecagon. Okay, I think un makes more sense to most of you because in Spanish you have uno, which means 1. Okay, so an undecagon is a decagon plus 1, which is an 11-sided figure. And then the other word for an 11-sided figure could be hendecagon. Okay, H-E-N with decagon afterwards. Okay, then we've got number 12. 12-sided figure, which is our dodecagon. Now, typically when we get above 12 sides, then they're just going to call it an n-gon, which means we have an n-sided figure, and an n-gon just tells us that. So if we had a 24-gon, that would mean that our polygon has 24 sides. Okay? So if regular means that all of our sides and all of our angles are congruent, then irregular is going to pretty much be the opposite of that. Okay, our irregular polygons are where at least one or more sides or angles is not equal to the others. Okay, so an example of this would be a parallelogram. Okay, because in my parallelogram I have opposite sides that are equal, but not all four sides are equal, and my angles are not all equal either. Okay, I have two different angle measures here. Now, you might say, well, what about in a rhombus? In a rhombus, I do have all four sides that are equal, but you still don't have all the angles that are equal, so it would also be considered an irregular polygon. Okay, so either one of those would work as an irregular polygon. Okay, a rectangle would also be irregular. You could have just a quadrilateral that looks like this. Okay, that would be irregular. You might have 90 degrees here, but then this angle and this angle aren't equal. Okay, so all of those would be considered irregular. Now the last two things on here are your perimeter and area, which we're not going to get into a whole lot right now, just the definitions. So the perimeter is the sum of all the sides of a polygon. Any polygon you can find perimeter. And then area is the number of square units needed to cover a figure. So that's how many boxes could I fit in this figure. Okay, and we can find the area of any polygon also. Okay, now moving ahead into our actual angles of polygons. Okay, when we look at these four figures, I have a triangle, square, pentagon, and hexagon. And I ask you for the sum of the interior angles. You should be able to tell me the first two. Okay, the sum of the interior angles of a triangle. Okay, we spent so much time on triangles. Okay, the sum of the interior angles of a triangle is 180. Now, the easiest way to think about that is that a triangle is made up of only one triangle and there's 180 degrees. Now, if we move, okay, and this has three sides, right? Okay, so three sides, 180 degrees. If we move to a square, okay, this has four sides, and if I draw in a diagonal, now I have two triangles, which means I have 180 degrees up here, and I have 180 degrees down here. So I would have 360 degrees in a square. Now, pentagon has five sides. Okay, I'm going to start from one vertex and we're going to see how many triangles do I have here. Okay, I have 1, 2, 3, so I have 180 degrees here, 180 degrees here, and 180 degrees here, which now means I would have 540 degrees in a pentagon. So let's look at one more hexagon, six-sided figure. I have one triangle there, one triangle there, and one triangle there. So 180 plus 180 plus 180 plus 180 gives us 720 degrees. So each time you see I'm adding 180 degrees to get to my other figure. Okay? So we're going to base our sum of our interior angles formula off of the fact that we're adding 180 degrees each time. Okay, so on our formula sheet, we start with our interior angle sum measure, which is going to be the interior angle sum equals 180 times n minus 2. Now that n is always going to equal the number of sides. Okay, so we should be able to determine the number of sides, and then that number is going to go in for n. Okay, now if I know the interior angle sum measure, if I want to find each interior angle sum, okay, then I take this, or each interior angle measure, then I take the sum and I divide it by the number of sides. Now, this formula can only be used if I have a regular polygon, because the angles are only equal to each other when all of the sides are equal to each other. And that's when I have a regular polygon. Now, our exterior angle sum, we're going to talk about this a little bit more later, is based off of the fact of a circle. It's not actually a formula at all, okay, but our exterior angle sum is always going to equal 360 degrees. That's That's just it, no formula to be used. Okay, and then if we know the sum is 360, then to find each exterior angle measure, we're going to take that 360 and divide by n. And again, that has to be for a regular polygon. Okay, so let's get into some examples using these formulas. Okay, our first examples are asking us to find the sum of the interior angles. So our formula for the sum of the interior angles is 180 n minus 2. So our first example is a decagon, which means we have a 10-sided figure, which means we say 180 n minus 2 with n being 10, so 10 minus 2, so 180 times 8, which gives us 1,440 degrees. Okay, our second one says it's a 30gon, which means we have n equal to 30. So here we're going to say 180 times 30 minus 2, and 30 minus 2 is 28. And 180 times 28 is going to give you 5,040 degrees. And that's it, that's your angle sums. Okay, our second set of examples is each interior of a regular polygon. And your each interior formula is 180 times n minus 2 divided by n equals each interior. Okay, now a dodecagon means we have a 12-sided polygon. So we're going to say we have 180, try to get rid of that, 180, 12 minus 2 divided by 12. Okay, when you put in 180 times 12 minus 2, make sure that you're putting those parentheses around that. If you just put 180 times 12 minus 2 without the parentheses, then you're going to get the wrong answer. Okay, now when you put that in the calculator, you're going to end up with 150 degrees. Okay, now you could do this in 2 steps in the calculator, 180 times 10, and then divide that by 12. Okay, so our second one, our n equals 24, and we have 180 times 24 minus 2 divided by 24. Again, you're just putting that in the calculator. Make sure that you're being careful. And here you should get 165 degrees. Okay? Now, our next examples are still based off of this formula, but instead of giving us the number of sides, they're going to give us the angle that we were finding here. Okay, so look at number 4 with me. Okay, it says the measure of an interior angle of a regular polygon is given. Find the number of sides, which means we're finding n in the polygon. Okay, so again, our formula for the interior each equals 180 n minus 2 divided by n. Okay, now here they give us the each interior angle, which means we have 150 equals 180 times n minus 2 divided by n, and we're trying to find n. So first we have to get rid of the n in the denominator by multiplying by n on both sides. Okay, then these get canceled and we're left with 150n equals, and then we've got these parentheses with this 180 on the outside, which means we have to distribute. So 150n equals 180n minus 360, and now we can solve for n. Okay, we're going to subtract 180n on both sides. Okay, and we get negative 30n equals negative 360 because this minus sign is attached to that 360. And then we're going to divide by a negative 30 on both sides. Okay, when we divide a negative by a negative, we get a positive. Okay, and 360 divided by 30 is going to be 12. Okay, so let's see one more. Okay, this one they give us the interior angle is 175 equals our formula 180 times n minus 2 divided by n, multiply by n on both sides. We get 175n equals, we're still going to distribute, where we get 180n minus 360. We're going to subtract 180n on both sides. And we're going to get negative 5n equals negative 360. Divide by a negative 5. And we're going to get n equals 72, not degrees, sorry. N equals 72, which means our polygon has 72 sides. Okay. So, moving right along, the next set says find the measure of each exterior angle. These are so easy. We do have regular polygons, and our formula is 360 divided by n, the number of sides. So, number 7, we have 360 divided by the number of sides, which is 12, because it's a 12gon. Okay. Sometimes they're going to say 12gon, and sometimes they're going to say dodecagon. And then 360 divided by 12 is just 30 degrees. Okay, our hexagon has 6 sides, n equals 6. So we say 360 divided by 6, which gives us 60 degrees as our exterior angle. And then this last one, 20gon, n equals 20. And we've got 360 divided by 20, which is going to give us 18 degrees for the exterior angle. Okay, we're just plugging in the number of sides to find our answers. Okay, these last two have 2 different steps to them. Okay, the first step is we have to find what the sum of the values are. Okay, and the second part is we have to find x, which is what they're asking for. Now, so the first thing you need to look for is how many sides does this have? 1, 2, 3, 4, 5 sides, so n equals 5. Okay, so the first thing we need to do is find the sum of the interior angles. Okay, so our interior sum equals 180 times 5 minus 2, or 180 times 3, which gives us 540 degrees. So now I know that all of these angles are going to add up to 540. So step 2 is when there's this many angles, I like to just line them up and then add. So we're going to say 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 plus 7x plus 0. Okay, and those are all going to equal 540 degrees. Okay, so we're adding the right column first. Okay, 5 minus 5 is 0, those cancel. 10 plus 10 is 20. Okay, then we're going to add our x's together. 4 plus 5 is 9, plus 6 is 15, plus 4 is 19, plus 7 is 26. So 26x plus 20 equals 540. And then you just solve for x. So we get 26x equals 520. And then we divide by 26. Okay, and x ends up equaling 20. Now, if they would have asked you to find what the measure of angle D was, okay, then you would have said 4 times 20 plus 5. So 80 plus 5 is 85 degrees. Okay? So you have to find out what the sum is first. Okay? So looking at number 11, last one, we've got the same idea. Okay, first thing we've got to look for is n equals how many sides? 1, 2, 3, and 4 sides. Okay, when we put that into our formula, now you should know if it has 4 sides, it has 360 degrees. Here we get 180 times 4 minus 2, so 2, and 2 times 180 is 360 degrees. Okay, so then step 2, we're setting up our equation, 17x plus 8. Okay, now you could add them going long ways. Okay, like this, plus 66, plus 110, plus 74, equals 360, or you could add them going up and down like we did on example 10. Okay, now when we add all of our numbers, here we're adding 8, 66, 110, and 74 together. We're going to end up with a positive 258. We don't have any other x's, so it's still 17x, equals our 360. And then we're still just solving, so subtracting 258. Okay, now we get 17x equals 102. Now we're going to divide by 17 and get x equals 6. Again, if they ask for an angle measure, then you would just plug that back into angle M and get what that angle equals. Okay, so that's pretty much all there is to know about finding the angles in a polygon. Okay? So good luck on your work.